And you know, I guess it's a much broader discussion, but obviously we could do an integrated model of all of these same choices that's aggregate in nature. I mean, I sort of wonder sometimes, why don't we just multiply the household counts or the person counts times, you know, the shares for each of these integrated decisions, right? Instead of simulating them. And
well, it's because you have so many millions of choices by the time you get down to the bottom level of the decision tree that it's not really feasible anymore. I mean,
okay.
some of our original work we tried to go that way, but it would take months to run some of those models.
Okay. So we have another question. Can we integrate walk trips into activity-based models?
Yeah, actually, we've had walk and bicycle trips in all the models we've done, and most of the other models in Atlanta and PC, San Diego. There's three main groups who are in the U.S. who are doing these models. There's Parsons Brinkerhoff. There's John Bowman and I are working a lot with the Resource Systems Group, and there's groups like Chandra Bhatt and from University of Texas, University of Santa Barbara, and University Ram Panyala at Arizona State. They're actually doing the model now for Southern California, Los Angeles region, which is based on work that was developed mostly for Dallas originally at the University of Texas. They're all, I mean, all of these models probably have more similarities than they have differences, but they do have some differences.
Okay.
Yeah, I don't know how I got off on that track, but
it's good to know, though. It is good to know. And then, okay, so we have another question here, which, again, I can't really speak to, which is when calibrating the destination choice model now, how to do that facing the large alternatives. What software do you use, Voyager or some others? Do you have a particular recommendation for multinomial loaded choice model estimation with large alternative sets?
If you're just doing multinomial and nested logit, I like alogit just because it's optimized for that kind of model, and it's, you know, you can estimate very, very huge models with thousands of alternatives and hundreds of parameters that even if you could estimate them in something like Voyager or some of the other packages would take days to estimate, whereas they, you know, take probably an hour or so or even less in alogit. So it's very optimized for those kinds of models. If you want to get to more advanced models like distributed parameters where you estimate mixed logit models and things like that, which aren't used very much in applied models yet, but in the more research context they are used. But the models, then you know, these other packages like Voyager and there's other packages around are probably a little more flexible in terms of things like that. And I mean, Voyager is free, which is a big attractive option of that, whereas the other packages cost money. But I think they're all pretty similar in terms of how difficult it is to use them. I mean, most of these packages are basically like learning a new programming language in a way. So I recommend alogit just if you have big logit models and lots of alternatives and big data sets. For smaller models, you know, it doesn't really matter as much. Just about any package out there will do nested logit and multinomial logit.
Okay. Any tips and tricks for estimation I can't think of any, but I mean, I don't know. I guess that's sort of tools of the trade, so maybe you don't feel like disclosing them. I don't know.
Yeah, modeling is more. It's more. It's more experience than any, like knowing what results make sense and what to do with your model. I mean, it helps having looked at hundreds of models.
Yeah.
Yeah, I can't think of one specific. I mean, basically check your data carefully, because a lot of errors in models come down to errors in the data processing that go into the models, and a lot of the programs, Voyager is pretty good at being able to report statistical summaries of the data that go into your models, but not only the parameters that come out, but what are the values that are going into each variable, and that's pretty important to check, because otherwise you can come up with an estimated model that you think is great, but it could be totally bogus because it's not based on the data that you think it's based on.
Mm. Yeah, important to remember. Garbage in, garbage out, as always. And that goes for the input data you create when you're running your model, too. I should mention, I meant to mention earlier that when you're talking about the inputs for forecasting and how we have to have, in this example, income by, income distribution and household size distribution, and maybe you'd want to use some additional variables in the future or something like that for a more complicated model. But CubeLand is capable of forecasting those things. We didn't show integration between CubeLand and the activity-based model in our CubeTown application, but of course it was performed in the case study in Thailand, and certainly, for local adaptations of this, we could definitely integrate CubeLand with the activity-based model to forecast the income distribution as necessary. Actually, I take that back. Now that I think about it, I think it is included, because if you do, I'd have to think about it. They're not in the same application, but actually if you ran CubeLand for a future year scenario in CubeTown, it would then, if you ran the activity-based model for CubeTown, it would then be pulling the data from that future year data set. So yeah, we can forecast those variables using CubeLand, as well as any other land use model you happen to be using that's of relatively good quality.
One thing I noticed in the Thailand application is that car ownership was actually used as a control for drawing the population.
Mm.
In general, in most cases, I would recommend actually predicting vehicle ownership as part of your model system rather than using it as an input, because a lot of things like fuel price, differences in fuel price in the future, or big changes in congestion could affect vehicle ownership, and there is a lot of evidence of that. The demo in CubeTown does have an auto ownership model in it.
Right. Yeah. Yeah, it's a good point. Okay, well, I guess we have no more questions. So this webinar will, of course, be archived for people who are wanting to see it, who are unable to view in the middle of the night in their time zone, things like that. And if later on you should have any questions, feel free to email me, Colby Brown, cbrown@clabs.com. And if a question is too advanced for me, maybe I'll forward it to Mark. And thank you, Mark, for your help and participation in this whole project, as well as today answering questions from our users and explaining a little bit about the background behind your model, which, frankly, I would have no idea what to say about if you weren't here. So I really appreciate your participation a lot. And Mark is excellent at building these models, so we really thank you for your expertise and contributing your thoughts today.
Okay, my pleasure.
Yep. All right. Have a great day. Take care, everybody. Bye-bye.